Hello everyone and welcome to yet another Zuzin session. How about that? How about that? I bet you didn't expect that shit to happen. So let's do 15th day of Advent of Code in the God's Temple. There we go. Chiton. I have no idea what that is. You've almost reached the exit of the cave, but the walls are getting closer together. Your submarine can barely still fit though. The main problem is that the walls of the cave are covered in chitons. Chitons? I don't know how to pronounce that. Chitons, marine mollusks of varying sizes in the class of blah blah blah. Okay, I see. And it would be best not to bump any of them. Alright. The cavern is large but has a very low ceiling, restricting your motion in 2 dimensions. The shape of the cavern resembles the square. A quick scan of chiton density produces a map of risk level throughout the cave, your puzzle input. For example, okay, so is that the Dijkstra? Okay. You start at the top left position, okay. Your destination is the bottom right position and you cannot move diagonally. The number of each position is its risk level. To determine the total risk of the entire path, add up the risk levels of each position you enter. That is, don't count the risk level of your starting position unless you enter it. Leaving it adds no risk to your total. Wait. The number at each position is its risk level. To determine the total risk of the entire path, add up the risk levels of each position you enter. That is, don't count the risk level of your starting position unless you enter it. Leaving it adds no risk to your total. I don't understand. Okay, whatever. So your goal is to find a path with the lowest risk, with the lowest total risk. In this example, a path with the lowest total risk is highlighted here. The total risk is here is 40. The starting position is never entered, so its risk is not counted. Okay. You set the top destination bottom right. Sounds like a dynamic, like 2-dimensional dynamic thingy. So yeah, let's go ahead and solve that, I suppose. All right, so in 2-dimensional dynamic programming, you would just have a table, right? And each cell basically represents the, essentially it would represent something like this. So we have a table and each cell of that table corresponds to the cell, right? But in that table, you essentially store the lowest risk, right? So if you start moving from this position to this position, right? So in here, you have the lowest risk starting from here and ending in here, right? So that means here and here, you have the lowest risk of paths from here to here and from here to here. And essentially what you can do, you can basically pick the minimal one between these two and add up this risk. And essentially you just do that for each individual cell. And at the end, you have the lowest risk in here, which doesn't give you the final paths, I suppose, but here you don't have to even have the final path. You only need to say the risk level. I would presume that the second part of this challenge would be to actually restore the path. So here you don't really need to restore anything. So yeah, let's go ahead and code that and see if it's actually true. So what's the size of the actual input? The size is rather big, not gonna lie. It's rather big. Anyway, let's go. New day, and it's 15th? Yeah, I think it's 15th. I think I also have to provide this thing, AoC 2021. All right, so I need to provide the password. So this is the sample, and the sample is basically this one. Okay, and let's quit that. And here we have to provide the input. Cool. All right, let's run the virtual machine. Okay, 15. So we're gonna start basically maybe chopping line by line. Right, so for that we'll need to allocate a line in here. While SV size is greater than 0, what we're doing, we are just chopping. Chop it like it's hot. Chop by delimiter. And we're gonna... So SV, the delimiter here is a new line, and we're chipping that into that line. And we probably want to actually print that just to see if it was correct or not, right? So also provide a new line in here. So we're doing the sample here, is the sample, everything's fine, but I don't think it's quite good. Because we don't store that anywhere, right? We don't store that anywhere, but do we even need to store that anywhere? That's a good question. Because I'm thinking, yeah, maybe we can actually do the DP sort of like as we read and as we parse everything. So if I take a look at the input, what's the maximum column here? So the column here is 100 and the lines is 100. So basically it's 100 by 100. Okay, cool. So that means we can have something like DP capacity and let's say 128, right? And I'm going to do the following thing. So this is going to be DP, DP capacity, and right, before doing anything, I probably want to do mem set DP size of, I actually have to set it to 0, right? And size of DP, so that actually sets everything to 0. That sets everything to 0. So it would be a little bit easier to, you know, initialize everything, like to sort of load that into the memory and like not do that in an online fashion, but I don't know. I guess it's fine. So what if we do something like this? So this is going to be for I equals 0, right? And then I plus plus. And in here, as we read the line, we're also going to iterate this entire thing. So this is going to be J. SV size, actually not. It's going to be J less than line, size plus plus J. There we go. So interestingly enough, so we have two situations when we have the left neighbor and when we have the upper neighbor. So we also have to take all of that into account. So essentially the easiest thing to do here would be to take the left one, right? So this is going to be the left one, and then take the right one. J, and find the minimum between them, right? So this is going to be the minimum, I64, and essentially do IJ equal to the line begin J. Right, so we're gonna add that thing in here, but we also have to subtract the 0 to convert this entire thing to the digit. So the only problem we're gonna have in here is that if we don't have the left one, right? So what if that one does not exist, right? That one does not exist, so we don't have to take that into account, I suppose. If that one doesn't exist, we also don't have to take that into account. So maybe we could do something like, I don't know. I would like to have like a variable that stores the maximum possible value, right? So the maximum possible value is going to be I64 max. Right, and if J is greater than 0, right, if J is greater than 0, we do something like A minimum I64 between A and this thing, right? So sometimes it's just like easier to retype it, right, in TempleOS. So we're going to do something like that. If I is greater than 0, then I is going to be minimum between I64A, DP I minus 1, J, like this. There we go. So in that way, we can just like do it like this. All right. So this is going to be A. But what do we do when both of them are equal to 0? That's a very interesting question. Right, when both of them are equal to 0, we want a to be equal to 0, so when you add this entire thing, you just initialize this thing to that. Right. So, do I have to have like a special case for that? Maybe. To be fair. Right. So what's going to be the best way to do that? I don't know. Honestly, I don't know. It's going to be the special case. So the easiest thing looks like if I equal to 0 and j equal to 0, just set a to 0, which is kind of dumb. Right, but I can't set it to 0 in here because otherwise this thing is never going to work out. Anyway, so after that, maybe I want to just like go ahead and print everything, but I still don't know the size of the DP. So I still need to know the size of this entire stuff. So let's actually go ahead and read everything properly because I don't know. Right, so let's call it a map. So maybe I'm going to call it map capacity. So let me actually do that. So let me do it like this. So DP capacity, I'm going to rename it to map capacity. And it's going to be over here, blah, blah, blah. Okay. So something like that. This is the map capacity and this is the map capacity. And on top of that, what we want to have in here is I64 map. Map height, map age, and map width. Right, map width. There we go. So yeah, let's not be smart asses in here. Let's not be smart asses. Okay. So how I'm going to be iterating all of that? I'm thinking that I'm going to start with map h equals 0, and I'm going to basically increment map h. And then essentially I'm gonna every time do map w equal to line size, and there we go. And in here, interestingly enough, at the end of this entire stuff, map w is gonna be exactly what I needed, so I can do something like this. This is actually kind of genius. Map w less than size, and this is gonna be map w. Right, so and essentially what I can do in here is just map h, map w, and it's gonna be a line begin, map w minus a. There we go. So and I can print something like dxd map h map w. So I'm going to do that. So it prints something. So it's basically 10 by 10, but I have a couple of unused variables. So it's 10 by 10. And as far as I know, it is in fact here 10 by 10, right? So is it 10 by 10? 1, 2, 3, 1, 2, 3, 1, and it's probably also 10. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. Okay, cool. So I might as well also test that on the actual input in here. It's 101. Okay, I see what's going on in here. So there's probably some extra thing that we want to exclude. And there we go, it's 100 by 100. So everything's fine. Okay, cool. Let's go back in here. And if I go ahead and print the entire thing, so probably need something like I64 row ij equals 0 I less than map h plus I. For j equals 0j map w plus j. Okay. D map I j. And if I print that, it is printing negative numbers for whatever freaking reason, which is in fact kind of sus, not gonna lie. What the hell is going on? Why would it print negative numbers all of a sudden? Oh, I know, because I'm an idiot. I'm converting incorrectly. Okay, so that's fine. Sure. Sure. So now what we're doing in here, I want to actually start with yeah, I essentially want to start with like setting up DP. I'm gonna memset, actually probably need to do something with memset dp0 size of dp. There we go. So here is that, and dp00 must be equal to. So I still don't understand. Like, what do you want from me? Something about entering, not entering. The number at each position determine the total risk level of each position you enter. That is, don't count the risk level of your starting position unless you enter it. Leaving it adds no risk to your total. What? What do you want from me? The total risk of entire path, add up the risk level of each position you enter. That is, don't count the risk level of your starting position unless you entered it, leaving it at no, well, and just like count the path, right? So count the path. Is that what it is? Like, I don't understand this thing. I think I'm dumb. Right, so I'm looking at the picture and it makes sense to me, but I'm trying to read the words and they don't make sense to me. So I think I'm just dumb when it comes to reading words, I think. So here we're gonna have this thing. All right, so I wanna basically first initialize this thing and this thing, so I can just like have, you know, 2D loop and just do everything what I want. Okay, so let's actually start with the columns, right? So this is going to be J. I probably want to move this entire thing somewhere here. Let's initialize everything here, just in case, whatever. So J, probably want to start from here. J less than map W plus plus J, and essentially dp0 J is going to be equal to, you know, adding up all of these things together, right? So it's going to be dp 0 j minus 1, but plus map 0 j, right? So that's basically what we have in here. So for the column, for the upper one in there. So then we're gonna have I1, I less than map h plus plus I, dp I0, right? dp I0, and then dp I minus 1, 0, dp I minus 1, plus map I 0. There we go. Cool. And the reason why I want you to have all of that is because now I can do something like 1. So I probably want to start with, yeah, I want to start with that. 1 I less than map h plus plus I, j j less than map w plus plus j. Right, and in here this is what I want to start, right? So dpij is going to be equal to max minimum i64 dpi minus 1 j dpi j minus 1 plus map I j. There we go. So that's the entire thing, and maybe now it makes sense to print that dp thingy because I want to see it. So let's go ahead and do that. So the result of the dp is going to be okay, so that's a lot. Maybe actually do something like 3. So that makes a little bit more sense, right? So the total risk level in this particular case is 40, but we end up with 41, which is rather interesting, right? So there's something about the risk level or whatnot. Don't quite understand why we ended up with 41. So should I not count the first one? That's what's interesting. Should I not count the first one? Probably. I can basically set that one to 0, right? Because I never actually entered it, right? So, and that one gives me 40, right? And I still can't quite understand these specifics. Okay. You start at the top level position. Your destination is the bottom right, and you cannot move diagonally. The number at each position is risk level. To determine the total risk of the entire path, add up the risk level of each position you enter. That is, don't count the risk level of your starting position unless you enter it. Leaving it adds no risk to your total. Okay, but here I don't think I ever enter the starting position, do I? I don't think I do, right? So why? This is so sus. This is so sus. I'm not sure. Okay, so I'm gonna just like set this position to 0, and I'm gonna try to use the input. So I should have not, by the way, you know, printed the entire thing. Okay, so what we can do in here, by the way, is basically print the final thing. Right. So part 1 is gonna be D. And in here, I just need to take the last thing in here. So it's going to map H minus 1, map W minus 1. And if I print that, it's 602, probably incorrect, right? So probably incorrect. So it's actually C, and it is correct. I don't fully understand the description. Like, I just, like, it pisses me off. Okay. You don't enter, but you never enter it. But there's so many implications, I don't understand. Okay, so part 2. I would presume that part 2 is basically trying to recover the path. Okay, so let's see how you recover the path. Now that you know how to find the lower risk path in the cave, you can try to find your way out. The entire cave is actually 5 times larger in both dimensions than you thought. The area you originally scanned is just one tile in 5x5 tile area that forms the full map. Your original map tile repeats to the right and downwards. Each time the tile repeats to the right or downward, all of the risk level are 1 higher than the tile immediately up or left of it. However, risk levels above 9 wrap back around to 1. So if your original map had some position with the risk level of 8, then the same position on each of the 25 tile would go as follow. Okay. So each single digit above corresponds to the example's position with the value of 8. On the top tile, because the full map is actually 5 times larger in both directions, that position appears total of 250 times. Once in each duplicate tile, the values show above the full 5 times as large version of the first above example, blah, okay. So equipped with the full map, you can now, okay, so this is the same problem, but with just larger input. So they were expecting you maybe to trick you into doing some sort of recursion, right? So yeah, and this is basically a case against the recursion, I think. Right, the total risk of this path is 315, the starting position is still never entered, so its risk is not counted. Okay, all right. So let's give it a try, I suppose. Let me see. So maybe I'm going to extract the reading of the input to a separate thingy. So that sounds great to me, at least. So let me remove this stuff. So it's 5 times as larger, which is rather interesting, which requires like 5 times larger DP, right? So we might as well just multiply this entire thing by 5. Right, so... and that should be it. Right, that should be it. So it's just an exercise in modular arithmetics, right? You just wrap things around. U0. Input, read input. Read input, there we go. So, and I'm just gonna copy paste this entire stuff. All right. So we also want to move 3 to here. So then I'm going to do a read input, and that is entire thing, I think. Okay, so if I try to run that, so we have a couple of unused things. So that means I want to move this stuff here. Okay, so that's cool. So let's comment it out. Read input. So mem set dp 0 size of dp, right? And then I set dp 0 0 equal to 0. All right, and so this one is interesting. So we know map w and map h, right? So, but we know that it's 5 times larger, right? So is it 5 times, right? I think it's 5 times. 5 times, yeah. Yeah, boy. I64 dp w is going to be map w multiplied by 5, and dp h is map h multiplied by 5. There we go. So, and let's also allocate some variables, some iteration variables, and let's start iterating. So, every time it wraps around, it just adds something. I don't quite remember, but whatever. So your original map tile repeats. All of these risk level are 1 higher than the tile immediately. However, risk level above 9 wraps around, so it's just like, yeah, it's modular arithmetics. So I might as well even just simply should be relatively straightforward, just like copy paste this entire thing and adapt things around. So here though we are iterating not from map w but dpw, right? So this is a dpw, and since it can overflow the map, what we have to do in here is basically modular. I probably need to move that on the next line. So modular map w, right, and that gives us how many times it was wrapped around, right? So how many times it was wrapped around. Well, no, it actually gives us the correct position, but how many times it was wrapped around is essentially plus this thing divided by that. There we go. And on top of that, we want to wrap this entire thing with 10. That's basically what we're doing in here. And we have to do that every time we are trying to access a map, if I understand correctly, right? So that's basically the entire thing. All right, so let me see. It's going to be map h. And then here we are adding... every time... Oh, this one is really interesting. So... each time the tile repeats to right or downwards, all of its risk levels are 1 higher. Okay, so I suppose... Okay, this one, 2, 3. But then if I go... Okay, so it's in both directions, right? In both directions they become higher. Okay, I see what's going on here. Right, so this is going to be basically map w, and you also have to wrap that around with 10. So there we go. Oh boy. So, and then it would probably make sense to allocate additional like variable a. Right, where I'm gonna keep all of that madness. A equal to map I mod map h, j mod map w, plus I divided by map h, plus j divided by map w, and all of that mod 10. Right, so all of that should be mod 10. There we go. And then we're going to add a. Cool. So, and after that, we just need to find the final thing, right? So I'm going to print part 2. Part 2 dp, and it's going to be what? Oh, this one is dangerous. I just noticed that I should have used dp in here, right? So yes. And this one is going to be dp dph minus 1, and this one is going to be dpw minus 1. Okay, so we're doing the sample, right? So we're doing the sample, and in the sample, 261. Is it 261? 261. It is not. I'm freaking out. 315. So this is something incorrect already. This is something incorrect. All right. Oh boy, oh boy, oh boy, oh boy. Where is my soy? So I probably made a mistake somewhere, that's for sure. That's for sure. So dpw, dp that. I hope I allocated enough memory for all of these things. Should be enough, actually. Should be enough. So we read the input and everything. Okay. So I'm iterating this stuff. J, right? Then I look back. And I'm looking at the current one, and the current one is just like J, but wrapped around with map. And how many times it was wrapped around is basically this. It's J divided by map W, and then we wrap it around with 10 just in case. So here we have I, dph plus I, so that's the other way around, I minus 1. So this is map H. Aha! Got him! All right, so this is H. Already found a mistake. Cool. So this is H, this is W, this is H, this is W, this is H, this is W, and it didn't really work at all. So that's really strange. 261 is 315. Yikes, yikes, yikes. I just made... So this is IH, I map H, map W. So, and this is A. So, where is the typo? Where is the typo? If I try to print maybe the entire thing, is it gonna work even? Is it gonna even work? So, 0 J. So I don't even understand how I can troubleshoot this entire thing, and I'm surprised that it didn't even change when I updated this thing. So there's no difference literally between that and that, right? So that is definitely not a mistake. So I kind of want to print the current state of this thing, if you know what I'm talking about, right? So if I just try to print from 0 to map H plus I for J equal J map W plus J, right? And in here, I probably want to do something like that. So, and this one is essentially map IJ, right? Map IJ, and this is going to be just a new line, right? So here is that. Now, if I try to do DP, right? So this is going to be DP, DP, but we are wrapping things around, right? So this is going to be map H, and this one is going to be map W, right? So, and I'm not sure if that's the same. We can quite easily maybe confirm that, right? By doing the following thing, I'm going to just add I divided by map H plus J divided by map W, right? So this is the thing we have in here, right? And then I'm going to do mod 10, right? So, and the way I'm going to actually try to confirm that this is the same thing is just going to copy paste this entire stuff and literally diff it. with whatever I have there. Unfortunately, TempleOS is not cooperating yet again. Right, so ed big map txt. Right, I'm gonna copy paste it in here, so I probably need to remove this kind of stuff, and there we go. Okay, so I'm gonna quit this entire thing, and then I'm going to maybe go to here, right, and just copy paste this entire thing. Just to see where I made a mistake, because it's really unclear. Sodding AoC 2021, where it is. So I'm gonna basically put it output txt. Here it is. Right, so here's the output. I probably need to mount my entire thing. So mount AoC 2021. There we go. Cool. And I'm gonna open output txt. And MNC, home, AoC, I cannot see shit. Okay, so there we go. So this is gonna be the big map. And of course, TempleOS is put something there. It's so dumb. Okay, so, all right, that's it. And of course it put a shit ton of garbage in here. Okay, does it look like the same thing? Maybe. So I can just confirm that. And there's already some differences, but I wonder what are the differences. Like I can't see them though. So the beginning and the ending are kind of like the same, but this line is not the same. So one of the things I can do here is maybe copy paste this entire thing in here and just do literally the diff between them, because like I don't see any other way to fix that stuff. So this is going to be big map, and this is the output txt. So what's the difference between them? Okay, cool. So the difference is on each line, but I can't see that because I'm literally blind. Okay, so let's take a look at this thing. So this is a big map, this is my, and the output, this is theirs. Okay, so what's the difference in here? Ah, I see. It can't be 0. That is very interesting. It just literally can't be 0. The author has Jebaited me. God fucking damn it. All right, so 9 wraps back around to... Okay, so yeah. You got me. Sure. Pat yourself on the back. God fucking damn it. All right, so we pretty much solved it. I mean, it's just like, it's already artificial complexity anyway, so it's pretty much solved. So the actual puzzle in here is just like to know about two-dimensional dynamic programming. That's the whole puzzle anyway, so whatever. Maybe we can have some sort of function in here that wraps around for things that are bigger than 10. So let me see, let's call it wrap. Wrap 10 maybe. Wrap 9. Wrap to 1. Okay. To 1. I64X, and in here what we're gonna do. So essentially we have a range from 1 to 9, right? We have a range from 1 to 9. We probably want to map that range to 0 to 8, right? 0 to 8, and right. So essentially, we achieve that range by subtracting 1. You subtract 1, and your range becomes 8, 0, right? That way, it makes it super easy to wrap this thing around with 9, right? There we go. So you still stay within 0, 8, and then you bring that range back to 1, 9, right? So that's essentially what you have in here. So that's the thing we want to have. Wrap to 1 is too much to type, so let's actually do wrap. That's it. No. Ah, shit, it's already taken. Are you telling me that it's already taken? Don't tell me that wrap is already taken by Terry. Okay, so what is it doing? Return angle and range. Oh, okay, so for geometry stuff. So there is a math. Huh. So there's a sine, cosine, and some other... Okay, I'll keep that thing in mind. There's a lot of mathematical functions in here that could be useful in advent of code. We have to keep that in mind. Okay, so RAP1. And in here, essentially what we have to do is just RAP1. I mean, we have to go through all of these things and do RAP1 instead of, modular 10 or whatever. RAP1. Fight. Okay, so RAP1, and if I try to run this thing, it does not even compile, because why? Forgot the semicolon. Imagine requiring semicolon in 2021. 315, right, 315. So now we probably don't need this printing. Right, we probably don't need this printing. There we go. 315. What about the actual input? Is that the correct one, by the way? So let's confirm. 315. I remember, yeah, it's 315. I remember that it was that. 2944, 2944, 2944, and fuck. My answer is too high. Alright, okay, so this is not a first try got cooler moment, which is kind of interesting. So the author has jebaited us yet again. Though, I think I did everything correctly this time, I'm pretty sure. So, alright. Is this another debate? Is this another debate? So the sample works correctly. Right, sample works correctly, but this doesn't mean anything. So maybe we still have an incorrect stuff in here, right? Right, so let's actually go ahead and confirm that. So I'm gonna maybe delete big map txt, right, okay. And let me grab this thing. It's gonna take some time. ed big map txt. I'm gonna copy paste this stuff. Boom boom. Is that the right one? Okay, so that's cool. So in big map we should not have any what the fuck is this shit? Why do I still have 0 in here? This is sus. Straight up. We should not have zeros. What the hell has happened? Do we ever have zeros? We never have zeros. Okay, we never have zeros. All right. So 1, you wrap it around by 9, so it stays. Oh. Yeah, this is because I'm an idiot, because I didn't use RAP1 in here. Alright, so that should be... That makes a lot of sense now. Okay, so... Wait. Okay. RAP1. Big map. This editor is so painful to use, you won't believe how painful it is to use. It's just like you literally feel pain and so slow, and it's just like okay, so I'm gonna go to map in here, and I'm gonna just like remove that thing, and there we go. So let's mount this entire thing. Mount AoC 2021. Cool. So here's the output, here's another stuff. So this is a big map from our thing, and this is the output from theirs. Did I mount it? Yes, I did mount it. Yes, I did. MNT home 2021 15 big map. Yeah. Why does it put that shit in there? I have no idea. Okay, cool. Alright, so that's fine. So it might be somewhere incorrect in here, but so far it is correct. So far it is, which is kind of sus, not gonna lie. Okay, so big map. I'm gonna go in here, I'm gonna copy paste this thing, and then we're gonna do div between them. All right. Apart from that, it's the same, it's just like it doesn't have a new line, which is understandable, but it's literally the same thing. It is literally the same thing, it is literally the same thing. So the question is, why is it so freaking high? Did I forget something? Did I forget something? Equip to the full map. Okay, so the total risk of this path is 300, starting position is still never entered, so its risk is not counted. Alright, so I don't know, so maybe I still have some mistakes somewhere. So there's like corny cases, they usually fuck me over. Alright, let me see. So the sample is correct. That's what's interesting about this entire stuff. The sample is correct. But what is fucking me over? What is fucking me over? I have a theory, a game theory. Just a second. If that's something TempleOS related, I'm gonna be very pissed off. I'm gonna be very pissed off. You won't believe how pissed off I'm gonna be. Because there is a huge probability of this thing being TempleOS specific. Though I don't see any problems in here, right? So that seems all right. So there's only like special character in here, and there's no special characters anywhere here as well. So that's fine. Right. So yeah, whatever. Let's run it. AoC 2021. Where's my tea, by the way? I need to sip my tea. Okay. We're almost there. It's just like, for some reason, doesn't want to work properly. Don't know why. Don't know why. I minus j, j minus I. Okay, and if I go to the sample, 2942, and it said that it's too big, right? It said that it's too big. So we initialize this entire thing. So is this J? I think this is J. Yes, it is in fact J. The depth. Then we're looking back and we're looking at the current one. And where we're looking is just we're wrapping this thing around, right? And the amount of times we wrapped it around, we increment that by 1. So we confirm that that's the correct way we're doing that thing, right? Because we compare those maps. So now I is the rows, right? So we look back. So we also wrap it around, and we add additional thing in there. Though that one is kind of. It's kind of sus, not gonna lie. But anyway, so then we're starting iterating this one and this one. So we're all using DPW and that stuff. All right. So we take I, map H, and J, map W, plus this is the amount of times we wrapped there, and this is another amount of times we wrapped there. Okay, that's cool. So DP I minus 1 is like the upper one. And that one, and just like plus A, and that's the thing. And here I just take the last one, which is, yeah, see any mistakes? See any mistakes? I really don't understand it. So it works for sample, but there's probably some sort of a typo that's haunting me, and I just don't see it. I just don't see it. So 2944 was probably not correct. So it just says that the answer is too high. The answer is too high. Did I not initialize something? I did initialize DP. I did initialize it. Did I need to initialize anything else? So the width and height in here. So let me take a look at the width and height maybe. So dxd. So this is going to be map w h map w. Okay, so I forgot the new line, of course. And what about dph and dpw? Okay, so that makes sense. Is it really 5 times? Right, so maybe I just multiplied by too much. The entire cave is actually 5 times larger in both dimensions. Where is the typo? It's probably some sort of a typo. Okay, let's actually make a small break, and after the break we'll try to find the typo, because this feels like just a typo error, right? Because like I'm 100% confident that that's the solution, right? So there's nothing else you can do in here, in my opinion. It's just like, yeah, and the font is not helping, of course. I'm gonna blame the font for this one. So I just spent countless amount of time double checking everything, and you can probably see how much time I spent because there is a timer in here, and after the cut you can calculate basically the time. And I came to a conclusion that I'm absolute moron, because you can go back, right? You can go back. That means this is not the classical DP thingy. It's basically Dijkstra. I'm not sure if you can like do something better than Dijkstra, but I think Dijkstra is a safe bet. But this is also super evil because the author made it look like it's DP, right? So the sample works with DP, the part 1 works with DP, but part 2, and I'm not sure if that's intentional. Is that intentional? But yeah, it looks like to solve the part 2, we'll have to implement Dijkstra. Luckily, I think we can reuse some of the infrastructure that we'll rebuild. I'm sorry that I'm scrolling around, they're probably horrible for the encoding. So I think we can just like use DP to store the sort of like a shortest path for the Dijkstra, though we'll need to implement some sort of a queue for this thing. So let's go ahead and do that. Right, I even retyped the whole solution again just to make sure that everything is correct, and it's the same problem. It works with the part 1, doesn't work with part 2, because you can go back and those find a better path, I think. So yeah, and that's what Dijkstra good at. As far as I know, that's what it's good at. So first of all, I want to kind of get rid of this weird stuff, right? Because it's not really convenient to type it out all the time. It would be way better if we had some sort of like an auxiliary function, a helper function that does all of that for us. So let's actually do something like big map, and it's gonna accept I and then J, right? Log for J. And what we're gonna return here, we're gonna do map I, map H, and then J, map W, and then plus J, map W, plus I, map H. There we go. So, and then we want to wrap this entire thing. There we go. So now instead of doing all of that, we can just call big map, and it will do this stuff for us. Okay, so, and essentially what we're doing, we are starting with 0. So, yeah, first of all, we probably want to store the best solution in DP, right? And for that, we want to fill it up with the maximum possible values, so it will trigger the Dijkstra algorithm to go that path and actually explore that path and find a better solution. So let me try to do memset I64. I hope it is working the way I think it works, right? So it accepts a pointer, the value, and the counter. Okay, so let's actually go there. So and in here we'll have to get the counter, and the counter is gonna be, let's say, dpw multiplied by dph, right? So, and for dp00, I'm gonna set 0. Let me actually remove this entire stuff. I don't think it's particularly needed. And we need an interface for a queue, which will allow us to queue a specific cells for the Dijkstra algorithm. Right, so let's come up with the interface. So first we need to know the size of the queue. So let's call it queue S, right? So this is going to be the queue size, I64. Right, so all of that is going to be based on the global variables, so it's a very simple program. There's no need to build an architecture out of that, right? So it's a throwaway program anyway. So, and then we need a way to enqueue something, so let's call it enqueue, right? So that enqueues the particular cell, so I, J. So I'm gonna... We don't really need to even return anything, I think, so I can just do it like that. And we also need to dequeue a cell. So I don't want to organize like some sort of a structure or anything like that. So let me just do something like dequeue, and I'm going to just pass this thing by pointers, right? So, and when you dequeue a particular cell, you just, it returns the values through the pointers, right? I think that's a pretty good approach. Okay, so, and in here, we're gonna do all of that while the size of the queue is greater than 0, right? So while the queue is not empty, though also I'm not sure if I need parentheses in here. So all right, but I need to enqueue the first position, right? So I need to enqueue it. Enqueue 0, 0. There we go. So we enqueued the first thing. Okay, after we enqueued the first thing, we need to probably dequeue that thing and go through all of the neighbors and see if the neighbors are worthy to be put into the queue and recycled again and stuff like that. See what I'm talking about? So let me see. So by the way, I forgot that memset has to be actually I64 max, right? So we need to mark all of them as the maximum values. All right, so dequeue I, J, cool. And I'm not sure if it's a good idea to call them IJ, so I want to call them current I and current J, right? Because I probably will need I and J for like the counter variables, right? I and J, so now I need to go through the neighbors, right? I need to go through the neighbors. So let me think. Can we have an array of neighbors of some sort, right? So to make it a little bit easier for us, so let's call it neighbors. Neighbors. We're gonna have 4 neighbors in here. Let's call it neighbors CNT, right? And essentially, we're gonna have only 2 things in here, right? So it's gonna be -1, 0, 0 -1, 1 0, 0 1. There we go. So I probably should do something like this, right? So I have to put curly braces in here, and also have to put curly braces in here. There we go. Cool. So we have neighbors, and I probably need to define this the neighbors count, right? And bors CNT, and it is going to be equal to 4. So, and I need to have a separate counter for those things, right? So 4n equals 0n less than n bors CNT plus n, right? And the first thing in here is essentially I equals ci plus neighbors n 0, so that's one thing. Then we're gonna have a j equals cj and neighbors n1, right? So that's what we have. And now we need to make sure that I and j are within the boundaries, right? So we can maybe have something like, we already have the full path in here, so it would be easy to actually check in here. So I is the rows, so that means we have to check it that it's less than I and less than dp h, right? So this is the first thing we check. And the second thing we're checking is whether the j is less than dp w. So, and once we figured that out, we need to probably check something rather interesting, right? So right now, dpij contains the safest path from the corner to that thing. That's the safest path. So we probably found a safer path. So when can we claim that we found a safer path? When the current safer path to ci cj plus big map ij is safer than whatever we have there. And if it is, I think we can safely enqueue I and j, right? So I think that's basically Dijkstra, maybe? I'm not sure, I don't remember actually. So I'm basically inventing this algorithm from scratch. And we enqueue I and j, right? And we don't even need to keep track of visited or anything like that, because if we found the best possible path, right, so we're never gonna actually visit that path again, right? Because, yeah, so we only visit the vertices when we find something better. Right, so this is the previous path, and this is the next thing, and when we enter it, and if it turns out to be safer, we actually enqueue it again. But before enqueuing it, I think we need to assign dpij to this specific value. Right, so this is the new path that we want to actually use in here. Right, so hopefully that will work. I don't know. So now we need to implement the queue, right? So we need to implement the queue. And this entire thing is going to go until you have something in the queue, right? So you do queue one thing at the beginning of the iteration, then you iterate through all of the neighbors, you see what you can add to the queue, and then, right, so then you continue. Okay, so how we're gonna organize the queue? That is a very interesting question, I think. I think that is a very interesting question. So we can probably define the queue capacity. So I'm gonna basically have a fixed queue with 2 pointers, like beginning and the size, and you will be able to basically enqueue something and dequeue something, like enqueue something from one end and dequeue from another end. So that's going to be the idea. So I'm going to have queue capacity, and the question is, what's going to be the actual capacity? So we have essentially 500 by 500, right? So it's going to be 10,000. I don't know. Let me see. 500 by 500. That's 10,000, 20,000. So maybe we can throw some sort of a panic if the queue is overflow. But just to be safe, I'm gonna put I don't know, 100,000. Why not? Memory is cheap. Memory is cheap, though I'm not sure. I'm not sure if it's cheap. Is it gonna fit into our memory? Because we have 512 megabytes. So let's actually see. Multiply by 8. So, and then I divide by 1000. This is how many kilobytes. It's almost a megabyte. I think it's gonna fit. So it's not that much memory. Like, I mean, come on. All right. So then let's define the queue. This is gonna be I64. The queue, right, so maybe just gonna call it queue, and the queue capacity, and we're gonna store like 2 elements in there, right? So this is gonna be something like this, and we need to keep track of the queue size. So let's actually keep it like this, right? So maybe because of that I don't need this function, right? Because it's like directly a variable. Then queue. Let me think. Maybe I need to have something like clean queue, right? Which basically clean up the whole queue, and for example sets the queue size to 0, right? So, and what we can do in here is just clean queue, right? And don't worry about that. But that's only the size. We also want to keep track of where the queue begins, right? So we're going to have also QB, and it's also going to be 0. When we enqueue something, We want to kind of check if the queue overflew, right? So that's one of the things we want to do. So let me try to do that. If QS greater or equal than the queue capacity, right? I'm gonna just do it like this, and I wish I could stop the execution of the thing. I know there's some sort of like a panic thingy, but I think it actually kills the whole operating system, if I remember correctly. Enter the debugger with panic. Yeah. So there's also some things like throw, and no, there is no such thing as throw, but rise. Maybe not. I don't really know how to assert in this thing. There's some sort of assert thing, and I still don't know how to use it because it's kind of weird. You have to use the hash sign, and yeah, I don't know. So we're gonna do that. Otherwise, we're gonna just print queue overflow, right? Something like this. I guess that's fine. Okay, so when we enqueue something, we're gonna enqueue that at the end. The end is located at QB plus QS wrapped around with the capacity, right? So this is wrap around Q capacity. So this is where it is located. So maybe I'm gonna actually put that into some sort of an index, I64 index. Maybe called place, right? So this is a place. There we go. And then I can do q place 0 equal I, right? And then q place 1 equal j, right? Is equal j. And then we just increment the queue size. That's it. So this is how we enqueue. We enqueue at the end of this entire thing. Cool. So here we also have an interesting thing. If QS is greater than 0, we're gonna do the usual thing. Otherwise, we're gonna print Q underflow, right? So this is the other way around. It's a Q underflow. Okay, so it's gonna be I64 place, and so the place is gonna be as usual QB. So it's actually at the beginning, right? So that means I can quite safely say I equal Q the beginning, right? So this is the beginning 0, and the J is equal Q the beginning 1. Okay, so and we need to increment the Q beginning, so we have to do QB plus 1, and that's going to be basically mod of the Q capacity, right? And then we need to decrement the queue size by 1. There we go. So we have enqueue the queue, we also clean the queue, and so on and so forth. So I hope I didn't make any oopsie doopsie and potential fucky wacky. So yeah. Okay, I want to see if this entire thing compiles without actually running, because I don't know if it's gonna work, like if it's ever gonna even finish working. Okay, so we have a couple of unused variables at 93 for whatever freaking reason. So place is not really needed in this specific case. So unused variable A in part 2, which is in fact true. I don't think we need A. And so far, so good. Everything compiles. And let me take a look at this sample, right? So we're going to run that stuff on a sample and get ready for an infinite loop. So it kind of worked, but it's not a correct answer as far as I can tell. Right, it is not a correct answer. It has to be 315, which is rather interesting, right? Which is rather interesting. Okay, that is very, very interesting. QB and Q size. So we can try to see what are the things we're visiting in here every time. So whether we are visiting anything useful at all. So that's a lot of stuff we visited, which is kind of strange. Did we visit like everything? Because that doesn't look good. That looks kind of sus. That is definitely kind of sus. So let me see. Oh, well, yeah, so that should be fine, right? So, neighbors -1. So we don't go overboard anywhere, hopefully. Okay, so let me try to print the whole DP in here. So for I equals 0, I less than DP H plus I, right, the usual thing. For J equals 0, J less than DPW plus J. And let me see what we've got. Did we got anything reasonable here at all? DPIJ. Right, so, and it's gonna be like a new thing in here. So there is a lot of weird stuff, but I think we need to separate this thing by a space and also get rid of this thing. So do we have anything reasonable? It does look kind of reasonable. So if we already entered something, right, if we already entered something, is that a bad idea generally? I don't know. So we're missing some stuff. We're definitely missing some stuff, which is not particularly great. I'm not super fond of like missing this thing, and I still don't understand the whole thing about like enter, beginning, not enter, and what exactly do I have to do with this entire thing with the enter and not enter. Like, it's kind of weird, not gonna lie. It is in fact kind of weird. So let me see. So if I just do big map I and j, will that change anything? That didn't really change anything, to be fair. So it's still like 5, but the final result is still 306. The final result is still kind of that, so it doesn't matter in the grand scheme of things. All right, so let me see. What's going to be here? Why would that not work? So neighbors CNT, there's 4 of them. And yeah. And it visits, it looks like it visits everything, right? So I don't think I've seen any of these things that are too big or equal to I64 max, right? So I don't think I've seen anything like that. So we can do something like this. If DPIJ is greater than 1000 or something like that, we're gonna print that thing just to confirm, right? Just to confirm this entire stuff. Right, IJ, let me see, and no, it is like it visited everything. I wonder how slow it works, for instance, on the whole input, and it works pretty slow, I'm not gonna lie. This is probably because we're printing a lot of also shit, so maybe we shouldn't do that. Right, so let me try to do this something like this. Okay, so it is working quite hard. It is working quite hard, but at the end it still finishes, so it's kind of fine. It is kind of fine. So there's something with entering things that doesn't make sense for me. To determine the total risk, add up the risk levels of each position you enter. That is, don't count the risk level starting position unless you enter it, leaving it adds no risk to your total. All right, so that doesn't really change anything. So to be fair, you can reach this thing with 0 risk. So I don't think you can come up with anything better than this. So I don't think you can. So, and in terms of big map, how did I implement big map? Right, it's a map H, map W, J, map W, map H. So honestly, I'm actually confuzzled. So I'm going to keep it +1, so this is on the flow. Right. So it doesn't even work on the sample. That's what's worrying, right? It doesn't even work on a sample. It must be missed something. So the current position plus the neighbor one, right? So we entered edit, so and we found something better than the current position there. So we are assigning that thing there, and we continue the algorithm, continuing the algorithm, and it just like doesn't really go well. Man, that is really tricky. So what is wrong in here? So maybe it would be nice to somehow recover the path. Also, let me confirm that yet again my big map is correct. So let me confirm that thing. So this is going to be a big map, right? And this is not what I wanted to do, right? So I want you to actually put this thing in here, right? And then just like a new line. Right, so again, it is not correct. I can already clearly see because I kind of remember, or is it? Yeah, it is correct actually. I thought it's like has 69 at the end, not 79. Okay, so and then it has 86 in here, right? So 100. So far so good. This map is correct. It is in fact correct, but it's not working yet again. CICJ. So we cannot go diagonally, right? So that means it's only -1, 0, 0, -1, 1, 0, and 0, 1. So diagonals don't count in this particular case. Right. So did I do everything correctly in here? So it's IJ and pointer to IJ, and then we just enqueue everything. Don't see any mistake actually. Don't really see any mistakes. So DP represents like the safest path from 0, 0 to IJ. So the safest path from 0, 0 to 0, 0 is 0, right? Because you never entered in this case, so you can't beat that anyway. Right. You really can't beat that. Though maybe because of that you don't want to start from here. Maybe you don't really want to start from here then. So can you go like literally back? Can you allow yourself to go back? Probably not. It doesn't really make any sense to go back. All right, so I thought maybe we just start from these positions then. Which is rather interesting because you start from here, right? Then you go here, and by going around like so, you may find something safer than that, which doesn't really make much sense, but maybe theoretically, right? And I'm surprised why I didn't find anything better, right? Like why? So it explored everything and it didn't find anything better. So which is okay. So I remember it had like 7 there. All right, so let's make another break. I need to think. Okay, I've got an idea. Can we even solve part 1 with the Dijkstra algorithm? Because part 1 is smaller and thus easier to visualize. So let's actually go ahead and try to do that. Right, so we're gonna use like the same algorithm. Right, but for the part 1. I hope I'm not gonna fuck it up. But anyway, so let me grab the entire queue. Right, so yeah, we'll need everything in here. And I'm gonna put it above. Right, so maybe below the DP. All right, so here it is. So, and for the part 1, let me copy paste the whole part 2 into part 1 and basically adapt everything. So, and the reason why I want to do that is because then I will be able to visualize the whole DP, right? It's rather small and we can clearly see if something went wrong. Right, so, so this is going to be part 1. So let me quickly get rid of this stuff. Okay, so this is part 1. So for this one, we're setting everything in here, so there's no dpw. I might as well replace dp underscore with map underscore. Okay, let me see. So Control F, dp underscore map underscore, replace within this selection. A boom, 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 boom. Okay, cool. So I wish I could quickly get rid of the selection, but I have no way except just like doing this kind of stuff. We don't have a big map in here, right? So it's not particularly defined. I think it's defined somewhere down below. Right. So map I j. All right, so it doesn't even compile because of why. dp, yeah, another one. So we'll have to do something like this. It's going to be map I j, and if I try to run that, it's 40. Right, was it 40? I think it was 40. There we go. So it is 40. So unfortunately, it is correct. Unfortunately, it is correct. Cool. Thank you very much. I really appreciate that. What we can do now, we can try to print the state of DP, right? So let's actually go ahead and print the state of DP. Is there anything available there? It's just like, it's literally the same thing, but with the bigger input. And why can't I just like do that? I don't know. Right, so everything looks fine. Right, so maybe we can even do something like this. That looks even better, as you can see. Right, but that's only the sample, right? So that's only the sample. So that doesn't give us much information about whether this entire approach even feasible. Right. So let's switch to the actual input, right? So do we have anything available? 602. I'm really surprised that it simply works, right? It simply works, which is extremely sus. Extremely sus, because what if just a regular DP worked? And I just made a very stupid mistake somewhere, very stupid typo. What if that's the case? That would be so annoying, because like, okay, so yeah, both of the approaches work on the first part and the first sample, but when I scale these things, they break apart somehow, and I'm really not sure why and how. And yeah, that's really, really interesting. That's the only thing it's the only way I can describe this entire stuff, right? So it's very interesting. Why is it like that? Who knows? Is there any differences? Like it's pretty much the same thing, right? So dpw, dph, so, and if I take a look at the sample, right? So the sample here works, it's 301, which is like not really what I want. It is not what I want. So if I put something like 2 in here, and it's kind of useless in here. For the part 2, it is useless straight up. So 301, and for the part 1, right, it simply works, but not for the part 2. Okay. So maybe it is the case. Maybe I made some stupid fucking mistake somewhere. But where? Where exactly did I make that mistake? Where did I manage to do that? So, is this really 5 times? It's 5 times as big, right? So, and big map, I take I. I is the horizontal thing here, right? And mod map is that one. Okay. So J map W plus I map H. And we wrap 1, which is like we're mapping it back to 0, 8, then 9 and plus 1. And right, so because there's only 9 numbers in here, we don't have zeros. Okay, so clean the queue, set it fine. So there's nothing particularly weird. Though now it doesn't even work on the part 2, so Dijkstra is basically choking. Maybe it's not Dijkstra, by the way, so I don't know why I call it Dijkstra, so it's just like my interpretation of this thing. Alright, but we're trying to find the shortest path for this entire stuff. It's bigger. This is the new one. And we enqueuing this entire stuff. So did I? Well, I mean, it wouldn't work on the first part then. It wouldn't work in the first part then. QBQS, then we are modding that. So IJ, QS++. Alright, so that is fine. We never actually overflow or underflow. So that is really weird. That is extremely weird. Never had anything weird like that. Alright, so I've run out of ideas, so let's make another break then. Right, just a second. I just realized a very interesting thing. This is not particularly correct way of setting this thing up, if you know what I'm talking about. Right. So, because it just sets this thing linearly. I think the easiest, like the safest way to initialize this entire thing would be just iterate it. So just in case, dp.h ++i, like so. So it was actually very careless of me. dpw ++, so is that j? All right. So and in here I'm gonna do dp I dpj equal I64 max. I don't know why I keep track of the width and height separately, because the size is the same anyway. Could have saved a little bit more like time on that, but whatever. So this is the sample, and let me see if that is a correct part 2 result for the sample, right? So all right, so okay, that is cool. What about the actual input? What about the actual input? So the actual input takes a little bit of time because my Dijkstra is rather poor, right? So I think the proper Dijkstra has to like have like a set that can quickly find the closest distance point and stuff like that. But yeah, so this Dijkstra is actually kind of sucks. 2935, and let's submit that. Bam! First try. Okay, I really like this problem. I don't know if it was intentional that the sample for both of the parts And part 1, they all can be solved with just a DP that always go down. I don't know if that's intentional. If this is intentional, just props to the author. This was a very good debate, which actually made me go in a completely, incorrect route. And then I had to realize that I need to implement like a Dijkstra and stuff like that. This is not Dijkstra, by the way. So let's take a look at how you implement Dijkstra. Dijkstra algorithm. So it's a little bit more efficient than whatever I implemented, right? It's a bit, okay, so we have something like this. Yeah, you create set of Q, right? So you initialize something and you find a vertex in Q with the minimal distance and stuff like that. So you probably use some sort of like a, I don't know. I think I've seen people use heap for this kind of thing, heap. Data structure to quickly find the smallest distance. So usually if you properly implement Dijkstra, it's like way faster than whatever I have in here, but I just like couldn't be bothered to implement efficient one, so it's like a couple of seconds anyway. It's literally 2 seconds, 2.4 to 8 to 26, so it's still pretty fast. So yeah, I guess that was the 15th day of Advent of Code in the God's Temple. See you in the next one. See you in the next one.